students. It's me again, Madam Gracious Kanzieni from Educare Tanzania. Welcome, my Form 3 student. Today we are going to start our series session of chemistry subject, and we are going to have our amazing topic, which is ionic theory and electrolysis. My student, before I proceed, I would like to say this for you. In this topic, we are going to cover some of the subtopic, which is the concept of ionic theory, the electrolysis and laws of electrolysis, and our last subtopic will be all about the application of electrolysis, how this electrolysis would help us to use it and to apply in our daily life. But my Form 3 student, I am hope that when you are Form 2, you are Form 1, you have learned about the concept of atoms, whereby you have covered or you have learned about the protons, electrons, how the electrons tend to move, how the loss of electrons and gaining of electrons tend to form the charged ion, negative and the positive charged ions, and how they conduct electricity. So in this topic, we are going to see details on how the electric current is conducted through those moving of electrons and so on. Now, my student, welcome today to start our subtopic, which is the concept of ionic theory. In this concept, you are going to see how these theories explain detail on the issue of ionic or the issue of electric current production. Now, the ionic theory was proposed by Svante Arrhenius to explain that during electrolysis, ionic substances, which are electrolytes, dissociate in solution to give random moving charged particles called ions. Kwamba hii ionic theories, hii idea ya ionic ilikuwa proposed na somebody known as Arrhenius, ambaye alikuja na idea ya kwamba when the alikuja na idea ya kwamba during electrolysis, wakati wa electrolysis, kwamba ionic substance ambazo zinakuwa ni electrolyte, those electrolyte substances tutakuja kuona mbele, they tend to dissociate randomly in the moving charged particles, ambazo hizo moving charged particle zenyewe tunaziita ions. Now, these ions are either positively or negatively charged, ambazo positive charge zinakuwa referred as the cation and the negatively charged zinakuwa referred as the anion. Now, the substances that conduct electricity have mobile electrical charged particles, kwamba ile substance ambayo ina conduct electricity ina ile mobile, ina ile movement of electrons, movement of these ions, which are positively and negative charged ion. Now, the movement of the charged particles enable the material to conduct electricity. Now, the way those charged particles, those cations and the anions, the way they move is where they are able to conduct the electrolysis. Some solid substances such as metals allow electric current to pass through them, while other solid such as non-metals and salts in solid state do not conduct electricity. Kwamba those metals, they tend to conduct electrolysis, but those non-metals, they do not conduct electricity. Also, those solid, those materials or substances that are in solid state, they are in distinct or distinctive manner in which they can't able to allow those moving of electrons and to produce electrolysis, so they do not conduct electrolysis. Now, most salts conduct electricity when are in solution or molten state, kwamba baadhi ya salty compounds or substances zina conduct electricity while they are in molten or solution state. The substances that conduct electricity refer the conductor, and those which do not conduct electricity are known as non-conductor. So we have two kind of substances here. We have conductor and non-conductor. So all substance which conduct electricity is referred or tunaziita conductor material, while those which do not conduct electricity tunaziita non-conductor materials. Now what is the electrolyte? Let us see what is the electrolyte, ambayo tuliona kwamba those electrolyte, those currents, electric current inakuwa produced to this substance, this electrolyte substance. Now what is the electrolyte? The electrolyte is the substance which dissociates into free ions when in solution or molten state, thus allowing the electric current to pass through it. Kwamba electrolyte ni yale material sasa ambayo yanakuwa katika molten or solution form, whereby they allow they tend to dissociate in free ions. So we are going to have the ion, you have to go in the charged ions. So if they tend to dissociate into free ions, mean that there will a movement of moving ions, free charged ions, and finally the electric current will pass through it. Electrolytes are either strong or weak, kwamba hii electrolyte material yanaweza yakatokea katika in form of strong or weak manner. Now when we talk about strong, what does it mean? When we talk about weak electrolyte, what does it mean? Let us see. The strong electrolytes dissociate completely in aqueous solution, where weak electrolyte dissociate partial. Kwamba zile strong electrolyte, this material which they tend to dissociate, they dissociate strong completely. But you can see the weak electrolyte dissociate partial. The common electrolytes are solution of acid, base, and salt, and their respective molten or fused state. Kwamba hizi electrolyte ambazo tunazizungumzia, the common electrolyte ambazo zinakuwa katika solution form, they can be basic solution, acidic solution, and sometimes we have the molten fused states as well as salty solution, salty substance. Now let us start with the dissociation of strong electrolyte. How this strong electrolyte dissociate, and we are going to have the free ions formation. Now the dissociation of strong electrolyte is represented by the full-headed arrow to indicate that the whole substance has dissociated into its respective ions. Kwamba yenyewe inakuwa represented by full ion arrows, full headed arrows, yani ile mishale inakuwa full headed, inakuwa imejaa. And the aim is to show that the compound dissociate completely. The compound dissociate with their respective ions, mean that we are going to have the positive ion and the negative ion respectively. Now consider the arrow. The arrow is look like this. So once you meet with this arrow, mean that this is a strong electrolyte, kwa sababu inakuwa ina dissociate completely. So mshale wake unakuwa full headed arrow, yani kama unavyoona hapa unakuwa this headed inakuwa ipo full directed, kwamba inaenda completely. Now let us see the dissociation of salt. Salt such as sodium chloride, lead 2 nitrate, and ammonium sulfate dissociate completely in aqueous solution. Kwamba hizi zenyewe kwa sababu ni strong salt zina dissociate completely in aqueous or molten solution. Now let us go through the examples of this dissociation of strong salt. The first example is sodium chloride. This dissociates in aqueous solution into free ions of sodium, which will be the positive charged ion, and we are going to have the chloride, which is negatively charged ion. So consider the simple reaction here. So you can see this is our salt, which is in solid state. So sodium chloride tend to dissociate when it reacts with water, dissociate in water to give the sodium ions, which is the positive charge, and the chloride ions, which is the negative charge ion. So you see this arrow here. This arrow indicates that this is complete dissociation kwa sababu their head of arrow is full. So it shows how it dissociates completely. Another example is lead-2 nitrate. The lead-2 nitrate dissociates in an aqueous solution into free positive charged ion, where we are going to have the lead, which is positive charged ion, and we are going to have the nitrate, which is negative charged ion. Consider the reaction here. This is lead nitrate, which is a strong salt. So once it dissociates, it will dissociate completely. Now, it tends to dissociate, and we are going to have the positive charged ion, which is lead, lead-2, and we are going to have the nitrate, which is negatively charged ion. Another salt is ammonium sulfate. The ammonium sulfate is the strong salt which tends to dissociate completely. Now, the salt dissociates into an aqueous solution or molten solution into free positive charged ion and the negative charged ion, whereby in the ammonium sulfate, the ammonia will be the positive charged ions, while the sulfate is going to form the negative charged ion. For instance, consider here the reaction. This is our ammonium sulfate, which is a salt, strong salt. And you can see the point of arrow here is full-headed arrow. It shows the dissociation completely of reaction. So we are going to have the positively charged ion, which is ammonium, and we are going to have the negative charged ion, which is sulfate. Now, let us see the dissociation of strong acid. We have seen those dissociation substances or electrolytes zinakuwa katika acids, katika bases, as well as salt, salt which are in solid state. Now, we have already seen the dissociation of salt, strong salt, how they dissociate. Now let us see the dissociation of strong acid as our electrolyte. Now you can see the strong acids such as sulfuric acid, there is nitric acid, hydrochloric acid, and the phosphoric acid. They dissociate in an aqueous solution or molten state into free ions. Now, the following are the examples on how these acids dissociate into free ions, how they are going to form those positively charged, cations, and those negative charged, anions. Now let us start with our strong acid, which is sulfuric acid. The sulfuric acid tends to dissociate into free ions, whereby we are going to have the hydrogen, which is positive charged ion, and we are going to have the sulfate, which is negative charged ion. Now consider the simple reaction here. So this is sulfuric acid, and here it is aqueous. In this bracket we have aqueous, meaning that this compound, this acid, is made up of solution or is made up of molten. Now we are going to have the hydrogen ions and the sulfate ions, and our arrow here, it shows that this dissociation is strong because it shows the full-headed arrow. Another is hydrochloric acid. This is another strong acid which tends to dissociate completely. Now, in this acid, this acid is going to dissociate in the aqueous solution into free positive ions, which is hydrogen, and the negative ions, which will be the chlorine. So the simple reaction is, this is hydrochloric acid, which is aqueous solution, means that they are in molten or in solution form. And this is our arrow, which point or which show that which is full head arrow, and they simply define that this is going to dissociate completely. Now you can see we are going to form our hydrogen ions, which is positively charged, and the chlorine ions, which is negatively charged. Another strong acid is phosphoric acid. The phosphoric acid dissociates in an aqueous solution into free positively charged hydrogen, and the negative charge will be the phosphate ions. And the simple reaction is here. So this is our phosphoric acid, which is aqueous solution or which is molten substance, and dissociate completely. Once you consider this arrow, is where you know that this compound dissociates completely, simply because there is full-headed arrow, and our product here is positive charged ion of hydrogen and the negative charged ion of phosphate ions. Now let us see the dissociation of strong alkali. We have already seen the dissociation of salty, strong salty, dissociation of strong acid. Now let us see the dissociation of strong alkali. In other way, you can see the strong bases. Strong alkalis dissociate into their respective charged ion when in aqueous solution, kwamba hizi strong salts strong alkalis zenyewe zina dissociate into their respective ions zikiwa katika molten or aqueous solution. Now consider those strong alkalis as they dissociate in strong alkalis. The first one is the sodium hydroxide. The sodium hydroxide, this is the strong alkali, whereby it dissociates in an aqueous solution into free positively charged ion, where we are going to have the sodium ions and the hydroxide ion or hydroxyl. For instance, consider our reaction here. This is sodium hydroxide, which is solid. The solid in nature, but it exists as the alkali and the strong alkali. So this is our full-headed arrow, which point that the dissociation is completely or strong, and we are going to form our product of two ions of positive and the negative. Another strong alkali is potassium hydroxide. The same. It's going to dissociate into two free ions, which is potassium, which will be positively charged ion, and the hydroxide, which is negatively charged ion. For instance, consider the reaction. This is potassium hydroxide, and this is our full-headed arrow, which points that the dissociation is strong, which will undergo completely, and we are going to have the potassium positive charge and the hydroxide, which is the negative charged ions. Now, my students, let's see the dissociation of weak electrolyte. We have already seen about the strong electrolyte. Tuliona kwamba electrolyte inaweza katokea katika njia mbili, ambayo ni dissociation katika strong electrolyte na weak electrolyte. Now, let us see the coverage of weak electrolyte. The dissociation of weak electrolyte is represented by two half-headed arrows pointing in opposite direction to indicate that part of substance has dissociated into respective ions and the maximum dissociation has reached an equilibrium concentration. Yani tunavyoongelea zile weak zenyewe zinakuwa zina dissociate partial. It is not completely, it's not the same with the strong dissociation electrolyte. So here, they tend to dissociate partial. So they are indicated, or you can understand this is weak electrolyte dissociation through the indication of half arrow. The arrow is pointed in half pointing the opposite direction, kwamba zenyewe zinakuwa half, so mean that the reaction inaenda then at the same time inarudi. So in order to form those completion, it goes and the product can also form the reactant. So they are indicated or represented by the two half pointing arrow, which are pointing in the direction in opposite directions. For instance, consider the arrow like this. So, and in this dissociation of weak, it involves this maximum dissociation, so as it can reach the equilibrium concentration, so as to show that this reaction attain the equilibrium concentration, imefikia ile equilibrium state, equilibrium manner. So what happened there? Inaenda inarudi, inakuwa na two arrows pointing in opposite direction. Afu zenyewe zinakuwa half, mean that ile ya kwanza na ya pili ndio ile reaction itakuwa complete. I hope you understand, my student. Now, let us see the dissociation of weak acids. Weak acids are weak electrolytes that dissociate partially in aqueous solution. The solution contains both ions and molecule of electrolyte. So tunapoongelea weak electrolyte au weak dissociation of this acid, tunaona ni kwamba ni zile ambazo zina dissociate partial. So kule kwenye strong tuliona zenye the way zinavyo react completely. Here we are going to see the way they react partial. For instance, we have ethanoic acid. Ethanoic acid, this is the weak acid, so it is going to dissociate partially. We are going to have the positive charge of hydrogen and negative charge of ethanoate. So we are going to have the negative charge of ethanoate compound, and we are going to have the positive charge ion of the hydrogen. So this tend to dissociate partial. Another example is carbonic acid. The carbonic acid, also this is weak acid, which dissociate into partial, in a solution into free ions, where we are going to have the positive charge of hydrogen as well as negative charge of carbonate ions. For instance, consider here, this is the carbonic acid ambayo hapa unaona double arrow, whereby it is half pointing in opposite direction, this direction, this direction, and we are going to have our positive charge ion, which is hydrogen, and the negative charge ion of carbonate there. Another is dissociation of weak bases. The weak base here also, they tend to dissociate in a partial way in a molten state into free positive charge ion and the negative charge ion. For instance, we have the weak bases like ammonium hydroxide. So this ammonium hydroxide tend to dissociate partial into free ammonium and hydrogen oxide in an aqueous solution. For instance, you can see this is our ammonium sulfate. This is weak. So we are going to have weak base. We are going to have the ammonium, which is positive charge ion, and we are going to have the hydroxyl ion, which is negative charge ion. Now, after looking the concept of electrolyte, the way they occur in weak electrolyte and strong electrolyte, we have seen of this electrolyte can be the acid solution, base solution, salty compound which are in solid states. But now we are going to see the concept of non-electrolyte. When we talk about non-electrolyte, is the vice versa of electrolyte. Kama tulivyoona kwamba electrolyte ni ile substance ambayo ina dissociate into free ions and the electric current can pass through it. It allows the passage of electric current, mean that this non-electrolyte does not do as electrolyte material or substance do. Now let us pass through. A non-electrolyte is a substance that does not conduct electric current in neither aqueous solution or in the molten state, kwamba yenyewe haya material au substance haijalishi zipo kwenye molten state or haijalishi zipo kwenye solution state, lakini zenyewe haziconduct electricity, has allow electricity to pass through it. Typically we have, when this non-electrolyte dissociate in water, they do not produce ion. You see, so even when they dissociate in water, has it produced zile free ions ambazo ni positive charge ion and the negative charge ion. So what's happened? For instance, we have the cyclohexane, we have the sugar. For instance, my student, once you take a sugar and dissolve it in water, it's very difficult to have the forms whereby electricity can be passed through them. Also we have cooking oil, mafuta ya kupikia. Those even are in molten state, even are in solution. Mafuta yale ni kimiminika, lakini can't allow the current to pass through it. Also we have pure alcohol, pombe. We have kerosene, mafuta ya taa. They can't allow the electricity to pass through it, though they are in molten. So non-electrolyte material are those substances which even are in molten or in solution state, they cannot conduct electricity. Now, my student, after looking the whole concept of ionic theories, I hope you have understood the lesson well, and for any misconceptions, I will see in the comments. Now, before I sum my session, I would like to provide for you the task. Why task? So as you can master the concept, you can improve your understanding well, and so forth. Now, the question is, what do you understand about the following terms? Unaelewa nini kulingana na terms zifuatazo? The first term is electrolyte, the second one is non-electrolyte, and another one is dissociation of a strong electrolyte, and the final term is dissociation of weak electrolytes. So try to attempt it for your own, and I hope you will understand more. Thank you for watching. Stay tuned Educare TZ for more series of our this topic of ionic theories and electrolysis. Bye bye, my students. Have a nice moment.